Hello viewers, welcome again to projection of lines. This is session 7 on projection of lines where we'll be continuing with the main problems. See here, please understand. This I've shown you already. Now the problems what we are doing here is inclined to both HVVP. Correct, no? Now you see here, in this problem, line is PQ, okay, capital PQ, red line, for which the top view you got it here, the front view you got it here, and the corresponding front view and top view we have written here. These things you already know. Okay, that means this is problem where it is inclined to HP parallel to VP. But what we are doing in these sections is the line will be not only inclined to HP but also inclined to VP. How we say it is inclined to VP means you should know at least by this three-dimensional sketch you will have a clear concept. See here the line is PQ, correct now? This line is PQ. Right now the front view is in true length. This is P dash Q dash at same 30 degree and all that. This is 60 mm only you do. And after that you draw the corresponding top view here, top view PQ and all that you do. But now what you do in these problems is keeping 30-degree constant with end P fixed. We don't change P. P is a fixed point. P always, you remember here afterwards, P is a fixed point. Q is a moving point. Now Q, I'll move it this way or this way. But when I move this way, Q is moving towards VP. When I move it Q this way, Q is coming nearer to the observer because observer is here. That means Q can be moved either this way nearer to VP or Q can be moved this way also nearer to observer. But whatever you do, the inclination to HP remains same. As a result, the distance of Q above HP remains same. That is the locus. Okay, that is the locus in the front view, in the same way top view and all that. This you know already, but I just want you to have a clear visualization of this. See here, this line is PQ. This is line. The corresponding front view is this. Top view is this. Don't get confused with the line and front view, top view and all that. This is the line which is in the space. Some 20 mm above HP and 40 mm in front of VP and all that. This is the line in the space for which you have written the top view as PQ and front view as P dash Q dash. Okay. This is the front view of the line. This is the top view of the line. As you know, you have to start from the front view only because front view is true length because it is parallel to VP. Front view you have to start from the front view. End P is 20 mm above HP. 20 mm above HP. You take it and then draw a line at 30 degrees, 60 mm and come down and get the top view at a distance of 40 because the line is 40 mm in front of VP. But what I want to give you the clarity here is how you rotate the line with respect to VP. Now you see it is 30 degrees to HP. It may be 40 degrees to VP, 40 degrees to HP or 50 degrees to HP, 20 degrees to HP, whatever it is that. Okay, let us say 30 degrees to HP. Fixed point is P. Moving point is Q. Keeping 30-degree constant, I'll start rotating this way. That is Q, I'll start moving towards VP. As a result, you are getting inclination to VP also. Now it is parallel to VP. Inclination to VP also. Okay. In the same way, that is fixed point is P, moving point is Q. I'll move this way also. Move this way. But inclination to HP is same only. When I move this point Q towards observer also, what you should know is inclination to HP remains same. Okay. And once it comes this way or once it goes this way, you should know very well it is not only inclined at 30 degrees to HP, depending on its movement, depending on the movement of Q. Okay. It has some inclination to VP also. Okay. That means once Q is moved either this way or this way, it will be not only the line is not only inclined to HP but also inclined to VP. In this position, when you see from the front, since it is inclined to HP and VP, in the front view also you see the reduced length. In the top view also you see the reduced length. This is the basic mechanism. Please follow. I tell you again. This is the end P, which is the fixed point. Q is the moving point. Keeping 30-degree constant, if I move this way, move the Q this way, that is if it is going towards VP, angle with VP gets developed. That means line will be not only inclined to HP, but also will have some inclination to VP. Okay. In the same way, if Q is moved like this also, that 30 degrees is constant. Q will be, once Q is moved towards observer and all that, the line will be not only have inclination to HP, but also will have inclination towards VP also. This type of problems are given here. The line inclined to both HV VP. It not only inclined at HP but also inclined at VP. In that way, front view as well as top view both will be apparent lengths. It will not be true lengths because it is inclined to both HVVP. As a result, its true length cannot be seen either in the front view or top view. This you remember, okay? See here. Now, next we'll go to the next problem. ND of a line AB is 15 mm above HP and is lying in VP. Okay, 15 above HP and lying in VP. This I've told you, it is not a parameter at all. Whatever is the thing given, you do. Now you search for the three parameters. The line is inclined at 45 degrees to HP. Okay, the line is inclined at 45 degrees to HP. That means the line is inclined at 45 degrees to HP. Theta they are given. This is theta they are given and measures 90 mm. True length they are given. Draw projections of the line when the front view of the line measuring 65 mm. That is front view is given 65 mm. In that way, front view is given, true length is given and theta is given. In that way, given the three parameters, you should be in a position to complete the problem. Okay. Now you see here. Now NDA of the line 15 mm above HP and is lying in VP. Please observe it is 15 mm above and is lying in VP. That is why in A dash you take 15 mm, A you take it on XY line only because NDA is lying on VP. The distance in front of VP is 0 means this A should be on XY line. Okay. Now after that, line is inclined at 45 degrees to HP and measures 90 mm. Okay. 45 degrees to HP and measures 90 mm. If you see this here, the line is inclined at 45 degrees to HP and measures 90 mm. Okay, 45 degrees to HP and measures 90 mm. Now, this A dash, B1 dash, let us say you call it, 90 you call it, one parameter is already over, second parameter is already over, two parameters are already over. But I have told you so many number of times, as soon as true length is given, corresponding other view should be parallel to XY line, which you immediately make it. Okay, A dash, B1 dash, corresponding top view is AB1, which is parallel to XY line, which you can rotate till it cuts the end projector or locus, whichever is possible. Okay, get ready for rotation. When you rotate, as long as inclination to HB constant, okay, the top view remains same. As long as inclination to HB remains same, the top view remains same. Top view remains same. Once you draw the top view, throughout the course of top view, the inclination to HP is always 45 degree. Okay, since top view remains same, I'll draw an arc A as center, AB1 as radius, I'll draw an arc. Okay, now I have drawn already two parameters. Okay, true length 90 mm and immediately I have written the corresponding top view parallel to XY line. Now you see here, the front view of the line, they have given it as 65 mm. A dash as center, you have already the locus, no? You have already 90 mm if you cut, you already have the locus. Now with A dash as center, 65 mm as the radius, cut it here. In that way, you are getting the front view also of the line. That means three parameters are already over. Now what you do, no? This is A dash, B dash. Take a projector from B dash. Okay. Take a projector from B dash. Somewhere here you should get B. For that, what you do? The true length is here. Corresponding other view parallel to XY line, which you can rotate till it cuts the end projector or locus. Locus is not there. At least end projector is there. You rotate till it cuts the end projector. Okay. Cuts the end projector. The wherever it cuts the end projector, this point is B. That is, this is B dash. This is B. Okay. Now, once you get B, draw the locus here. Now, as you know here, this 45 degree is over. This is anyway given. This is 65, that is also given. 90, that is also given. Three parameters, whatever they are given, that only you show. Other things you have to actually determine. No, let us say this is alpha, no? Alpha, you measure this as measure this angle and call alpha is so much. And this is actually beta. This is top, you know. This is, you call it as beta. What is beta? You measure this and put it here. They are the answers. Everyone should get the same answer. They can't have different answers. That is why you list the answers. Now you see here, more or less the problem is over, but only thing is, theta is given 45 degree, but phi is not there. Okay, that means phi is not there. To get phi, that is true length in the top view, what you can do? One procedure is take 90 mm, A as center, 90 mm as radius, cut it here, draw the true length. You are getting phi also. Otherwise, also I have told you in the last session, rotating the front tube parallel to XY line and hitting against the locus will give you the true length and true inclination. Okay, this also you can do. Okay, what I have done? I rotated the front tube parallel to XY line and hit against the locus, and I'll join this and this. Okay, join this and this. Then this will be what? Phi. This will be beta. This will be theta, what is given. This will be alpha, what exactly to be found out. See here, this is nothing. This is rotation of front tube parallel to XY line and hitting against the locus. You will get the true length and true inclination. This already you know, but I have made it as a procedure because if true length is found in the top view, corresponding other view should be parallel to XY line, which you can rotate till it cuts the end projector or locus. It is the same thing. Other way of telling is rotation of front view or top view parallel to XY line and hitting against the locus, you are getting the true length. This also you remember so that you can do the problems very fast. Okay. Now you see here. Now I have got this. Now I have got this. See here. This is 45 degree. It is theta. Theta you write. 45 degree is that is given. This is front view is given. True length is given. What you have to do is this you call it as alpha. Alpha is front view inclination or apparent inclination with respect to HP. You write whatever is the angle, maybe 66 degree or 67 degree. You write alpha is front view inclination of the line with respect to HP. In that way, this is beta, no? Beta is top view inclination or apparent inclination of the line with respect to VP. Okay, this is alpha, front view inclination or apparent inclination of the line with respect to HP, right? Whatever is the angle. In the same way, AB, this you call it as beta, and you say the apparent inclination of the line or top view inclination of the line with respect to VP, whatever is that, you just list it out here. And in the same way, this is phi. This also. This is actually the true inclination of the line, true length inclination. True inclination of the line with respect to HP, that you need not do because they have given in the problem. This is theta. But phi you have found out actually. Phi you do. Phi you call it and you say that is the true inclination of the line with respect to VP is this theta. Okay. True inclination of the line with respect to VP is this. This is top view inclination of the line with respect to VP is this. This is alpha. This is phi. This is beta. This is phi. This is alpha. Standard terminology. Okay. Alpha is front view inclination of the line with respect to HP. Front view inclination of the line with respect to HP or apparent inclination of the line with respect to HP. This beta is top view inclination of the line with respect to VP or apparent inclination of the line with respect to VP. This is phi is true inclination of the line with respect to VP. Okay. In that way, you have completed this problem. Okay. You have completed this problem. And where I have told you after writing XY line, A dash you have written 15 mm above HP and A you have written it on XY line because they are clearly given NDA is lying in VP. If they say NDA is 15 mm or 40 mm in front of VP, push A 40 mm in front of VP. Okay, NDA is lying in VP, that is why put A on XY line. Okay, if I say NDA is at the intersection of HP VP, then put A dash also here only. From here only you start everything. Okay, if NDA is at the intersection of HP VP means NDA is also in HP, NDA is also in VP. Under such circumstances, A dash and A both will be here only. Okay, anyway, now we have come to the end of session 7 on projection of lines. We'll start with projection of lines section 8 shortly. Thank you very much for watching. Thanks again. Thank you.